Okay, and this last video here is kind of optional. It's just some practice for you guys to get used to transformations. But there is a problem at the end of this video that I think you'll find very interesting because it's unlike the things that we've done before, but it's simple enough to understand when we go through it. So what I want you to do is when you see the equation written up there, I want you to try to graph it on your own and then compare it to what I put up here on the video. So each time you get to this point, pause it so that you have a chance to graph it, and then take a look at what you have. So pause it. Alright, what do we know about this graph? We know that it's left one. Well, first of all, it's an absolute value. It is left 1. It's twice as steep, but it is reflected across the x-axis because of that -2. That's what the graph looks like. Alright, try this one. Okay, you should have rewritten this one because of that -x in there. So it should have been 1/2 negative x minus 4 minus 2. So this tells you that it's reflected. This tells you that it is right 4, and this tells you that it is down 2. Okay, reflected across the y-axis. So, it should look like this. A parent function would look like that. It's reflected across the y-axis, and it's stretched out. Actually, another way to think about that A term, I've mentioned skinny and I've mentioned fat. A better way to look at it is it either stretches or compresses the graph, okay? So if you have a regular parabola like this, and there's a number greater than 1, say it's 3, 10, whatever, it takes and it stretches that graph really tall. Okay, so what that does is it means instead of going through the 1, 1 point, it's stretched so high that it goes inside. The 1/2 does the opposite. Instead of taking that graph and stretching it, it takes it and it pushes it down so that it's half as tall as it should be. So if our normal half parabola for a square root graph is up 1/1, when we squish it, it's going to be up 1/2 and over 1. Try this one. Alright, again, we should rewrite this. -3 x minus 1 squared plus 2. Okay, so this tells us that it is flipped across the y-axis. In this case, it doesn't change anything because if a parabola looks like this, when we flip it across the y-axis, it still looks like a parabola. This tells us right 1. This tells us up 2. And this tells us that it's flipped across the x-axis. So instead of being up, it's going to be opening down. And it's 3 times as steep. It stretches it out by a factor of 3. So it looks like this. Alright, moving on to this crazy example right here. We're going to call that graph f of x. And I want you to think about how you would graph it under the following 4 separate transformations. Okay, let's take them one at a time. Notice that I have the parent function in there so that you can see it. F of x plus 2 means that it does what? It moves left 2 spots. So the graph would look like this. Same exact graph, just moves left 2 spots. How about this one? F of x minus 3 tells us that the entire graph goes down 3. Just like that. Now if you remember the way I just explained how to use the A term, instead of this graph being what it is, it's stretched out vertically by a factor of 2. Well, in this particular case, rather than think about it being skinny or fat, recognize that the y values are just going to be twice as big as they are in the normal graph. So first we want to think of those coordinates of those endpoints, and then think of what is the y value at those coordinates, because we just have to double it. So our first one, starting from the left, it goes from a positive 3 to a positive 6. And the next one goes from 3 to 6. Then 5 to 10. Then negative 2 to negative 4. And negative 4 to negative 8. Okay, so each of those y coordinates, all I'm going to do is double them. Then all I have to do is connect the dots. Okay, so you notice that the normal graph was like this, and all we did was we stretched it by a factor of 2. How about the last one? Okay, if it's inside the parentheses, that means it's reflected across the y-axis. So what you're going to do essentially is take that entire graph and just pivot it around the y-axis, like this. Okay. Hopefully that's some good practice for you guys and you know exactly how to do these problems now. Sayonara.